1, 2, that's a 0. I've lost track. How many? That's 6, 5.
I know.
4,
First of all, if you live in Mill Woods, Tapascan, is this your cat? Because I've got him. I know, you're cute.
So this says a nim sum of 1, 2, 4, 8.
You want
so
it?
the nim sum here is 9. So I'd have to remove 9 to be in a hot position.
Let's just play the game.
Nim. Hey, where's the cat? It's right there.
How many is that? Do I have to have an odd number? Does it matter when you have?
I don't think it really matters.
So you go first then. What is the rules again? You tell me the rules.
Well,
You can remove 1 or 2, but they have to be.
as many as you want.
Oh, that's right,
But
as
it
many
can
as
only
you
be
want.
from 1. See, yours is circular. This is how he does it. So yeah,
It's logic like this, but this is what I'm saying. This is how you have fun with kids,
so
and then you ruin
I
it.
need to get a nim sum of 0, which means I need to remove 9. So I'll take 9 away from here, and that'll leave 2. And now it's your turn. Your goal is to keep a nim sum of 0. So now this is.
So what have you done?
I took out 9 from, and it's got to be from one of the groups.
From 11 then?
So I took out 9, so now the nim sum is something else, so you'd have to recompute your nim sum.
You're playing a different avatar of the same game,
Yeah.
I guess.
Anyway, the point is the person who takes the last one loses in this nim.
You're fuzzy.
Hi, here, come over here, say hi. Oh, we're going to hand you Kitty around. You're so light.
The way I do it was like this, and so now no matter, this would be the integer 2, and then you're allowed to take as many away as you want, or they can add other rules. So say I take those 2 away, the key I want to do is, without having to calculate the nim sums, is take that away first of all, because what did that do? It's made it into 2 disconnected sets now. And then now I just mirror your moves. We can color the moves. If this was the first person, green is first and second is red. Then if you do this, no matter what the kid does, I just mirror image them.
It's just like tic-tac-toe.
Yeah, but I think this was all, or yeah, that's roughly, did I mirror it exactly? No, because it should have been this one. That's okay. And then because it's 2 components, you can't do them where they're disconnected, I think. There's different rules that I would do, but then I would just do this one. And then there should have been an extra one in there. You're not allowed to add them in there. But then, yeah. Do you see? That's sort of saying the same thing, I think. But now he's just taking it to where, yes, there's the nim of, I'll find you the sheet.
Sure. Let's
You
introduce
go
everybody to Clancy.
take the cat. I collect them. My daughter names them. Clancy has another name. I think his name is actually Link. Or that was the first one. She was naming them Zelda. There's a girl in the neighborhood that has them, but she also doesn't like to neuter her cats or spade her cats and just lets them run free in the neighborhood. But then they all gravitate towards my house. My house is a cat sink.
If you're going to die and be reincarnated, come back. And visit Adrian. You can't go wrong.
I know. You like me?
Ooh, look at the tum-tum.
Oh, kitty.
Oh, I love your cross eyes.
Session to grown-ass men fawning over cats.
Oh, Wood, I didn't know you were fluent in catfish. I am. Would you? I know. You know how to get them so that this is how you get them when all the pointies are this way. So then when you have to administer something, that's how you do it. I've been scratched by many a cat. Not as nice as you. I know. They can't see you down there.
That is so
Lovable. Come here.
cats at home. I really can't add another one to the crew.
I can't hear you because the mic's on.
The
Oh,
mic's on me.
on.
Ha ha ha.
Yeah. I was going to say, well, okay, I got to look. There's the camera, but I got to look over here. Fuck.
Then I'm doing.
I don't know what I'm doing. The point
Ba.
is I have too many cats at home, so
There you go.
that's right. So what are you teaching
Cat
today?
company.
I don't know the legal limit. I'm gonna do similar to what I was doing on. Let me show what I did on Friday.
Oh, you got the mic.
I was
Take
angry.
note, it's a chalk. It's a chalkboard. Fuck.
We also have a projector
Oh,
screen
shit, yeah.
that we forgot about, but I just noticed it in the. Go back to your home. No, I have the same amount of trouble in the classes with me. So Noah's probably here.
Yeah, he said
Okay.
that to us.
He's finally dedicated. He's learned that I'm prickly on the outside. How do porcupines make love? Very gently, very gently. All right. So what were we doing? I can still see the turtle. I like turtles.
Everybody does.
Arbitrary thoughts of a madman. Can we just do that?
Sure.
How do you take any odd number and create a Pythagorean triple?
Ooh. Well, that's a good one. How do you do that?
Which I was looking for Nim and I came across this in my math 160 notes, and then that's how my brain works. I stopped looking for Nim and I just read that instead. I was like, fuck.
So is that the mathematical equivalent of, oh, look, squirrel?
Yeah, squirrel, please be my prisoner. Subjugate them. Please. He did the dog. He's too nice. Please be my prisoner. So yes.
I love the way
Except mine's cat. Look, cat.
Yeah, this looks really good, actually.
So if P is odd,
A year after we put it up. Looks good.
just wait.
Die Hard.
I gotta feel that. I'm gonna do a Die Hard. I'm doing a Die Hard. Actually, maybe we should do a Die Hard with Academia. Do a Die Hard. What's in this? I bet it's a cat. It is a cat. You can't see, but there's all kinds of games and books and just a horde of them next to us. What's in these ones? Some book in Russian
To me,
that I got from Mark, and I don't know what it's about.
Mr. Dress Up with all the
Oh, yeah.
distractions around here.
Plus, no, I want to be the guy after my friend.
Bicycle trunk.
My friendly giant, where he's so high he's talking to a giraffe that comes to the fucking window. I don't know what he's on, but can I have some of those? It's probably a Jeffrey. Can you prove to me, or let's just prove it, if P is odd? Here, let's go from the video game sort of too, because Dan and everybody treats me as persona non gratis. I can see why they would want to be guilty by proxy or not be guilty by proxy. I see Othello over there too, the game. And Mario. Oh, look, this one is representation because it's the girl one, Mario. Girls can play checkers? Yes, they can.
There you go.
So, if this is in World, I haven't written on chalk in a while, so yes, we do have a chalkboard. You're welcome, Noah. This is going to get my hands all sucked dry. Just my hands, though.
I'm not touching it.
I want to go to equation. I want to go to equation land. How do I get? Or we just switch from world to land? I don't know which one it is. It doesn't matter. So what does that mean to be odd? It was similar. It ties into what Tim was doing, and then that's why I sort of was like, oh well, this is odd because what is odd? It means you leave a remainder by 1 when you divide by 2 consistently. If you're trying to do nim, you have to calculate mod 2. So what that means is P is 2k plus 1. I want to use Q, but then what we're going to do is, and then can you give an algorithm for, after I rant on this, can you give me an algorithm for, this is the understanding and the logic of everything, but then most people don't want that. They want to step 1, do this, step 2, do this, step 3, make profit. Step 1, steal underwear. Step 3, make profit. What's step 2? Proof goes here. Proof goes here, everybody. Proof goes here. The magic you're missing in your life is in the work that you avoid. Bum, 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 bum. So now this is 2k plus 1, and my claim is this. This is what you would do first, or what Sir Isaac Newton would call scholium. The one that you have theorem and lemma and corollary, but the one that they don't give you anymore is scholium, which means he doesn't have a proof of it, but he's pretty sure it's a good idea. The spooky action at a distance, he didn't know why gravity was working that way. But claim, first of all, then you have to, this is logic, and then we'll meta-logic it immediately afterwards. Claim, P odd implies P squared is odd, which is corollary to a larger theorem.
And that was on Math 260 about a month ago.
Was it?
Yep.
So here's the theorem, actually. If P and Q are both odd, PQ is odd. No, PQ is even. PQ is odd. Oh no, that one, does that one work? Yes. And then the corollary would be this.
Not a car made by Toyota.
Corolla.
Old joke.
Corollary. So then that gives you the context of this. A corollary is a statement which immediately follows from a larger statement. Why is it a corollary? Can you see why though? They don't point it out. Nobody said they had to be distinct P and Q. So you just let P equal Q, and then that's P squared. Then P times Q would just be P squared. Do you see why it's a corollary now? Anyways, you proved the big theorem also. But there should be about 4 statements on that. If you take, no, is there more than that? If you take 2 odd numbers, you can add them and multiply them. If you take 2 even numbers, you can add them and multiply. 6. You can take an odd and an even number and add them and multiply. And then you can always know, if you do this ahead of time using the definition, which you're going to get. So I claim that P squared is going to also be odd. Proof. So now we're going to meta logic. So this is logic. Either it's a true statement or it's a false statement, and it can't be both simultaneously. That's logic. Meta logic is proving the statement. And unfortunately, there's the undecidability theorem, which says that there are statements in any axiomatic system which can't be proven to be true and can't be proven to be untrue. But this one could be. One of the examples of what we think may be so far is, are there infinitely many twin primes? We can't tell yet. Nobody's proved it. Nobody's unproved it. But once you prove it, there's no such thing as new math. New math is an oxymoron. That's laughable to me, new math. Not unless you're doing a PhD is it new math.
Unless you get a field medal for it, really.
Yeah, because once I prove that this is true, you can't unprove this statement. So what am I going to do? And my mantra is, when you take 200 with me, what do I have? What do I need? Indeed. If it rhymes, it must be true. If the glove fits, you must acquit. Doesn't fit, but it probably did fit. Maybe he put it in water and shrunk it. I love Norm Macdonald's jokes on these constantly. That's how he got fired. That's why he got fired from Saturday Night Live, was because he wouldn't stop doing fucking OJ jokes. And he got there, and then somebody sat him down. Let me do an analogy here. Somebody sat him down and gave him the heavy and said, if you don't stop doing those jokes, because we're going to tell you what you can and can't say, it's like, no, you can't. And then Norm just went up there and showed him that he can say whatever he wants. You can give him consequence for this. I know, I said it's an analogy. Read between the lines. I'm fearless, even though I know they're going to take my job away. Fearless. Proof. So what do I have? I have that P is odd. In terms of equations, that means he's 2k plus 1. What do I want to prove? I need that P squared is odd. What would that look like? He should be 2q, let's call it, plus 1. And then we're going to FOIL everything out and see about this. And then what do we need? Indeed is this. This is the step. This is from the gnomes. This is step 3 from the gnomes. Step 2 is in the wrong order because he never thought about it this way, but the proof, indeed. So, but the indeed also tells you what do you need is the most important part. What do I need to do? I need to look at P squared, and then somehow using the things I have, I need to find that it was a multiple of 2 plus a remainder of 1. Indeed. Which I like the word because it's actually what is that? A verb?
Indeed.
I'm about to go do it in the deed of doing it.
Right. Yeah, I don't know if that's X.
Me fail English. Rich just used that's impossible on the last. Did you see this? I was like, he said what I said. I'm making it because I'm as smart as Rich Evans. Yes.
You gotta do the laugh.
I can't do this. This is his own. I can't steal this from him. Everything else. But your mind knew it.
You may not have noticed, but your brain did.
Okay, let's do the proof. Also, this is a discussion. It's not just PowerPoint. How fun was that? I'd already be done. But you got to listen to my rants to get the information out of me. Noah, you should be done this proof already by now. What does it say? I don't have my laptop is backwards now so
No one said.
Rick's in the way, so just wait. That's usually my look at the camera guy. So just a
I
sec.
should actually drop this curtain and put that guy up so you look at the camera a little more.
I was like, what the hell? Yeah, here, just wait. You're going to knock everything. Oh, rock, paper, scissors, lizard, Spock, which is the complete graph K5, which means you're non-planar. Yeah, put that over there so that I know what's going on. I'm watching Dune again also.
Is that the first one? Or
The
second?
first one, I got to start at the beginning because I never read the books.
Oh,
I know, and then now I've just ruined it because I watched the movies before the books could create my own imagination. Stop watching the movies,
I gotta watch
people.
the second one.
He says as he admits that he's freely not watched this. Stream manager, is Noah talking? No,
I
he.
just said hi. I'm sorry for ruining the chalk. Right, that was after your chalk comment.
Never say sorry. Never apologize. I'm unapologetically myself. I'm also putting this on. Just one of them.
Well,
It's from a game called You've Got Crabs. And my daughter really wanted it. And I'm like, I don't think you get the entendre of what they're trying to say here, though. So I've got crabs.
that's another South Park. Look like crab, talk like people, crab, people.
Hey.
Crab
No,
people.
no. If this was Fallout, you'd be a Mirelurk. Oh, come on. Everybody's all up on my Fallout game. TV show.
Oh, yeah. Now I see what you're saying.
I haven't played the game.
Tim's way ahead of me on half the things. I have to catch up to what the hell he's saying. Crab.
Mirelurk.
But yeah, squirrel. I just saw a crab claw, and I'm like, I'm going to put that on the live stream. Should I put both on to see if I can actually chalk? Yeah, let's do it. I've got two. I don't know what they're for in the game, but I'm like, we're buying that right now. I'm like, I don't know why I don't have any money for my mortgage. This will actually stop the chalk. How come this one's not as good as the other one? Okay.
Are they supposed to be on different?
Are they parody? Are they chiral? Fuck, I think Lorenzo was. They might be chiral. Let's find out. I'm not gonna give him any credit for it. They were chiral. Frick. No, it still is awkward. You're stupid.
That's what you get for being smart.
Smart. SMRT. Smart. Okay, this is not working. This has gone south. You want me to open up this? Probably not. Naked ladies in the form of a skeleton. Yeah. Salvador Dali, live art. If it's in art, it's okay, I guess. Okay, proof. What do I need? I need to look at p squared. Because I need to show that there's a 2q plus 1. I'm stepping on stuff, including chips. All right. So that's what you should start with. This is the idea of how it's like, this is the most frustrating thing that nobody helped me with, that I had to carve out myself. And then you start realizing, oh, I could make a whole regime from this. So what do I have? So first of all, the first step is it's backwards. Maybe we'll have to flesh this out. But you have to ask yourself before you start the proof, what have they given me in the antecedent? They're going to say, if you have this, then I can show this. And you're like, I don't know how to start this every time. And this is extremely disconcerting. But there is sort of a structure to it because it's always just modus ponens. So I have to ask myself, what do I have? What did they give me? And what do they want? And so they want this thing to be odd, which means it'll have to look like 2q plus 1. And then all I have to do in this scenario is now, hopefully, this is called Hans Brungs from the U of A was my number theory instructor. And he said, I like to make problems where they're like, I call them 1 or 2 corners, maybe 3 corners for the proof, where you'd have to look around a corner to cleverly get the idea. And he's like, these ones are just straight down the hallway if you know the definition. So throw your hot dogs down the hallway. Hey, a Boeing 747 looks small in the Grand Canyon, all right? So let's look straight down the hallway and say p squared. What do I know about p squared? It's 2k plus 1 squared. And why do they call that squared? Because if you had in geometry something that had sides 2k plus 1, that would be the area of the square. There's a completion of squares in there somewhere. But now I ask myself, am I allowed to, what's the definition of squared? It means multiplied by itself, length times width, which would also show you that if you were using the geometry. So there, even when I'm doing algebra, I draw a picture for Mark. You're welcome, Mark. Now what do? I know that this is a vector space over itself on Friday, I pointed out. I showed them a whole bunch of vector spaces and scared them, and then did linear transformations of vector spaces. But I showed that every finite dimensional vector space is isomorphic to Rn for some copy of n also. We'll do that in a second. But I know that these are numbers which are real numbers as a subset. They're positive integers. And what am I going to do? Technically speaking, I can distribute this whole thing onto there, or first, outside, inside, last. I'm going to FOIL it however you want to memorize this. What do I get? I get 4k squared. It's probably better to remember that there's a 2 in that. So 2 times k squared. I'm going to write it like that. So I multiply the first ones, then I can multiply the last ones, then I can multiply the inside ones, and then I can multiply 1 times 1. That's technically times 1. I'm just applying the rules of algebra, the 10 axioms. There's no difference. This is what's magical once the light goes on in your brain. You get 10 rules. There's no more than that. That's all you're ever allowed to use in any computation further unless you prove another modus ponens result. And then you're allowed to use that and then what you have. And then if you can just keep gathering that into a larger and larger basket, we'll tear down the whole system. So now what do I have? I have to see that in this, I can group this together. What do I want it to look like? I want it to look like this. So I'm going to write 2 times, what do I have? 2k squared. I'm grouping them together. And then this one I have 4k, so then this is going to be what? Plus 2k. And then I have a plus 1. This is my q. So what is that? 2 times something plus 1. So by definition, p squared is also odd. QED. So that was not necessary. If I'd had a PowerPoint, this would have been awfully boring and I would have forgotten and I wouldn't have even done that. That wasn't the point. But I claim this, and you should stop just taking this. Even these little statements, every time you get one and you're not sure why, you should either ask the instructor and then you go to their office hours or whatever, because that'll be beyond the scope of this class, et cetera, or prove it for yourself. You don't have to wait for people to show you. But in my mind, the way that my mind works, especially these days, was I'm going to claim that I'm going to take an odd number and then I'm going to square it. And then I said, well, how do you know that that's odd? I just proved it for you. So we just got meta. So now I'm going to take an odd number, which means he's 2k plus 1. But now, without loss of generality, I don't really need that anymore. What I want to do is now square it. So step 1 is take an odd number and square it. I know now that that is 2q plus 1. But then people that are actually paying attention will say, well, why do you know that? I just proved it. What is q? Q is 2k squared plus k. I factored out the 2. There was a 2 in them. I'm allowed to do this distribution in reverse also. Axiom. The systematic application of them, it doesn't change. And this is what everyone says, you're a wizard. It's like, no, I'm just systematically not telling you that all I'm doing is applying these axioms over and over and over again. And look at the theory that falls out. Now what were you doing? I was going to make a Pythagorean triple. I wrote it up here to remember, to rememberize this. So now what do I want? Do you see cleverly? Let's take any other number, q squared. So take any other, now, I don't care whether it's odd or even, q. Square it. Then what are we going to do with that guy? Can you see? Add 0. What is that, the wand or the staff or the hammer and the saw?
Let's keep with the wand and staff analogy.
Okay, so let's add the wand then. So I took this guy, I added 0 technically, or what you do to one side, you do to the other one. So let's use the axiom that says I can add that to both sides. Do you see what's happened? Oh, it just gave me a Pythagorean triple. And then if you can't see it, this is where you have to take theory. I've done this with a bunch of numbers, or somebody did. And this is the problem with math also, is that you're doomed to live life forwards and understand it in reverse. So this is not some, well, possibly. I can't claim that this is inside the minds of all these great people. I want to reference Plato, but I'm going to digress. Nah.
Digress, but on Twitch.
On Twitch, I probably could. Plato says one of the penalties of not getting into politics is you end up being governed by your inferiors. And I didn't play part in all of these things. Let's do it with an example is what I'm saying. They don't come up with that statement without doing a whole bunch of examples. And they're like, every time I do this, this seems to work. And then you have to phrase it into the generalization of the proof. But then you see it in the book and you're like, that's backwards. So this is the problem with math textbooks and what I want to do in the... We should do a podcast, Lorenzo. Oh, shots fired. Shots fired. He's been asking me to do that for a long time. Oh, the chalkboard does look quite good, actually. A little bit lower, a little bit lower. You can't see my crotch in the shot. Which is a good this is a good thing. So let's
Wear pants anymore.
I'm just going to say, we can take a poll right now. Is he or isn't he wearing pants in this screen?
yeah, I'm Donald Duck in it right now. How do you know?
Winnie the Poohing it.
Back to COVID. Winnie the Pooh in it. Just wait.
Oh God, no!
I've got a Winnie
Oh,
the
no,
Pooh.
he's taking his pants out.
No, oh, there's a Winnie the Pooh, but he's not up there. I'm sorry. I gave the Winnie the Pooh to Mark Solomonovich. Oh, that sounds like I was wearing no pants and then I gave Mark something. No, that's not what I meant. How dare you? Hey, look, an eraser in the form of a cat. What?
Lace in the form of a cat.
Oh, it is too.
A witch cat. Which cat is that? Stormy. That's Pusheen's.
Pole dancer's name.
That's Pusheen's younger sister. That checks out. All right, so let's take 3. Do you want to see why the Greeks called 5 the number of marriage? Probably maybe we shouldn't get ourselves in trouble like this. It was the Greeks.
History, that's fine.
2 is the first. What did they call this? Weird number. I don't know if I spelled weird right. I don't know if I can know. And then so these are non-weird numbers.
You're right for weird.
So the weird. And so these are no. What the analogy was men are odd and women are even. And then now, do you see where I'm going to go with it? Yep. The uniting of a man and a woman, which are complements of one another, gives us 5. So 5 is the unity of 2 and 3, which is the number of marriage. And then I have 1 for each one of these guys, each one of these numbers. I can't remember them all. It's in my history of math book.
What was it? Yeah, I remember you brought that up in history.
Yeah, and it was like men are the odd ones, and I was like, thank God the Greeks made it men were the odd ones, because then otherwise I'd have to say women are odd and men are even. They were trying to build. Pythagoras thought everything can be built from this. Anyways, let's take the smallest. Technically, 1 would be the smallest, but I don't think we can get 1 because we want. Let's see if it works. Let's not even hypothesize. The problem was Q going to give us this? Will 1 work? Can you see? I don't know why I keep dipping over there because they're behind a veil. Is this the Wizard of Oz? Damn it! What does that make me? The wizard, or are you guys behind the veil? I'm just the freaking straw man.
You're those munchkins that roam around with
I think I'm the scarecrow that has no freaking. No, I'm not that. I'm the tin. I must be the Tin Man then. I'm Toto the dog. Because the. Well, maybe, I guess. Maybe I should be. My job will last longer. There's a 0 quotient. How much 2's is 1? 1 is no 2's plus 1. But I need a non-zero quotient in that algorithm caveat. But that still shows you, because now do you see Q is 0? And Q squared, therefore, is not distinct. So it doesn't work. But that also, do you see, this also helps out knowing where I want to start with. So you have to pick an odd number larger than 1. 1 is odd because by definition it leaves a remainder of 1 when I divide by 2, which is also good to do. Also, when you do negative numbers, how do you do negative 3 divided by 2? They usually don't do. Do you do this in the 260, etc.? Oh, that push.
Tell me what you're going to do. Right now it doesn't look familiar.
You have to go over. The remainder has to be positive.
Oh, if you're talking about the modulo stuff, they do that in 160.
So it has to be negative 2 times 2 plus 1. Do you see? The remainder has to be 1.
Right.
So when you do it with a 3, which I'm about to do,
So you overshoot it.
you have to overshoot negative to get negative 4 plus 1 in the remainder. Otherwise, it's not unique in the division algorithm. That hurts their brain. I usually suppress this because for most of the algorithms I want to use, I don't need the negative numbers. Diophantine equations is the only one, but I can absorb the negative into my algorithm, which I did. Let's do that next. So let's try 3, 5, 7. There's the only, there's Tim's favorite gun type. And it's the only triple,
Not wrong.
it's the only triple primes, 3, 5, 7. Because if you take any other 3 numbers, p plus 1, and p plus 2, what do we know about one of these? Can you articulate it? Tim knows, I think.
One of them has to be even, or
And one of them has to be divisible by 3.
divisible by 3, right?
Yeah, so then it ruins that.
Yeah.
But even these two, yes, one of them has to be even. Well, again, that's the rules that we just talked about, the corollary rules that I just gave behind this, because there's 2 cases, right? Metallogically, P is even or P is odd. But if P is even, adding 1 to it will make an odd number. And then what I'm trying to say, yeah, actually that's an easier proof than the proof that I gave. Stop correcting me, Lorenzo, but that was better than the proof that I was going to give. I didn't even need this guy. Okay. Okay, yeah. All right. Let's digress. So let's do 3. And then what's the next one? Okay, 9's in there. I don't like him very much, but okay. 11, 13, there's another twin. So what we're saying is this might be an undecidable question in mathematics. Are there infinitely many twin prime pairs? Because this is a twin prime pair, and this is a twin prime pair. But it's the only triple. 11, 13, 17, 19. What's the next one?
23.
Next prime is 23, but he's not a pair. 29, 31, that's correct. What's the next one?
41, 43.
I think it jumps to that, yeah. There's a whole poem on TikTok you can find about the 101 Dalmatians. 102 is poop, but then 103 gets banger again. What are they actually referencing? This is also a twin prime pair. It's not the next one. But this is the pattern that they start seeing. They start seeing that there's infinitely many primes that differ by 1 even integer. But nobody so far has proved that there isn't infinitely many of them. And nobody's proved that there is infinitely many of them. There's another catfish that I want to talk about. In the proof of Euclid's proof that there are infinitely many primes. Just let me write it down or I'll forget to prove this in a second after I do this. Did you know that that quotient in there that he creates isn't always prime? You're like, what? Just a second.
Okay.
Yeah. What's the fallacy in there that you would think that? You're using reductio ad absurdum. Just a second. Yeah. It blew my mind too. I stole that from Richard Guy. I came up with that independently on my own. Richard Guy made it to 101 though. I don't think he made it to 103. In 2016, he turned 100, and then I gave a Taurus talk about him with Natalia Zadarnova. She talked about how he met him mountain climbing in Jasper. I talked about all of his results mathematically. I don't think he made it to the twin prime 103, but then you've made it as a mathematician. If you make it to 101, then 103, lottery. All right, 3, 5, 7. You're like, you just wrote them down. It's like, because now I want their 2 factorization, which will help Tim in NIM. There's a mod 3 card game I could show you too, but then don't show the students because they'll hurt their brain. on the calculator. I'm calculating mod 3 when you flip the cards, and then it hurts. It's like, just do it in your head and memorize it, and then don't show the students, and then it's magic. The magic of magic is it's not magic. See that there's a pattern in there? Euclid, you're in the way. Move, get out the way.
Luda. Ludicrous.
Yeah.
Tim,
What?
Is that ludicrous, or I thought that was...
it's ludicrous.
I don't... Oh, yeah, you're all right. You're all right. Yeah. He also is not going to stop till he gets him in the birthday suit.
Right.
Ba-ba-ba.
That was him, Usher, and Lil Jon.
What? Okay.
That's right.
Yeah. Let's go.
Then on the
We shouldn't do it on the live stream because someone will steal it, but I'm gonna do it anyways. I wanted to do a whole thing where we do YouTube shorts musically about sound bites from songs out of context because they're hilarious. Like, what? Okay, let's go. It's like, what do you? It's like the sound bites without the rest of the song are just weird. Anyways, there's my thought.
mine would be Creep from Radiohead.
There's a bunch of them.
I'm a creep.
But that's not a sound bite. That's a part of the lyrics, so you're not picking up what I'm throwing down, though. But you were brave enough to try, anyways. Wrong.
What else is a soundbite? So you mean just like something that's
Yeah, like from 21 Pilots, they just have an eagle go by. It's like, what's that from? It's like to try and guess the song that the sound bite is from.
that's I like that.
Right? Yeah, and then I shouldn't have said it live on stream because fuck, now we're screwed.
Well,
Oh,
no, I mean there's
what happened here? My hand doesn't even listen to me.
three.
Let's see if they have to be. This is something I also wanted to know, and let's see if it ruins it, but it shouldn't. Oh no, that's why, because the Q plus one, and a Pythagorean triple, they have to be 2 odd and 1 even. They can't all be the same parity. Parity meaning divisible by 2. Do you see why? The P is odd, right? That's what I'm starting with. Then the Q can be odd or even. But then the other number I pick is Q plus 1, which you just used in your other proof to show that there wasn't going to be any of those. So then you're going to use Q squared. If it's even, then it'll be even. If it's odd, it'll be odd. But then Q plus 1 will be the same.
Oh, right, that has to be the same thing.
So they can't, if these two are the same parity, then that one's not. If these two are the same parity, then that one's not. Right?
But Q and Q plus 1 have to be the same.
3, 4, 5. 5, 12, 13. Yeah, they can't be all the same parity. Can you prove that? Oh, wow, 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 wow. Okay, focus. What were we doing? Now what do I need to do? In each of these, you need to add 1 to it. So this is the algorithm. Take an odd number, square it. Oh, wait a second. What have I done wrong in the algorithm? It's just going to shift it. Step 1 is square the odd number. Uh-oh. Can you square all of these? So now we're going to get 9, 25, 49, 81, 121, palindrome, 169. And then 14 squared is 196. How I remember that is you square it. 15 squared is 225, 16 squared is 264, 17 squared is 289, 18 squared is 324, 19 squared is 361, 20 squared is 400, 21 squared is, I don't know. 441, and then 22. I don't know. I haven't gone that far. I do it pedantically. See, so Tim has done this. You have to memorize them. I'm doing it pedantically to show you. You're like, oh, you're just showing off. It's like, no, I get to the end to where I have to stop, and I haven't memorized that far. But I use squares quite a bit, and so does Tim. So he's invested the time to memorize them for yourself.
Get to the end of the song like Eric
But
Cartman,
wait.
and I'm sailing away.
Yeah, yeah.
Every following perfect square is the sum of the previous one plus the next number you're squaring. Because if you look at 24 squared, that's 576, but 625 is simply 576 plus 24 plus 25.
Which will help in finding the square root of numbers.
Oh my God.
I want you to say that later again. You said it live, but they can't hear you. But okay, focus. Otherwise, the stream will be over. I gotta go do Mabel stuff, I think, possibly later. So now let's find the quotients if you can't find them. Can you find the quotients? Because these ones are gonna jump now. So this should be, no, let's write the 4 times 2 plus 1. This one's gonna be what? 49 is going to be what? Oh, if you don't know, this is what we're doing every time. So I want a 2 in there. If you can't see it, see how also I did that? I am terrible with numbers. Holy Christ, it should be Tim up here now because I don't know how. It was 48 and half of 48 is 24, right? But this is good because if you can't see it, most of the students don't remember. They're like, that was grade school stuff, but do you see what I'm doing? This will give me a 2, and then I get a 4, and then I get a 0, and then I bring the 9 down, and I guess what? I get a 4, and I get an 8, 08 if you want, and I get a 1. And what that says is 2 times 24 plus 1 is 49. And then it's the analogy for improper rational functions. If I was going to do that, do you see? Then I get 49 divided by 2 is a whole number plus a number between 0 and 1. We're going to do a tangent quickly now. There's a complete analogy there now between that division algorithm and polynomials. So if I have let's call it A and B in proper rational functions when we're doing integration using partial fraction decomposition. I'm going to divide A of x by B of x. There's a trick in there, but essentially what you're going to get is a q of x, and then you're going to get where you're going to stop at r of x when now the number's not less, but the degree of r is strictly less than the degree of b. My divisor, dividend, quotient, remainder. You want your money back in dividends, multiples of the original amount. Dividends. I know, that's as far as I'm going to go with that. So now what can I do with this? This division algorithm of polynomials, and especially this condition, does what? Even if I don't have a proper rational function, if I have a of x over b of x, what I now do is I take the division algorithm and I write it as a of x is q of x times b of x plus r of x, where r is the degree is strictly less than b. Then I divide by b, just like I did with the numbers. So now I get a polynomial and a proper rational function. Now if I want to integrate that, power rule, partial fraction decompositions, if I have this proper guy, these ones will come into a natural logarithm or an absolute value or an arctangent. There's partial fraction decomposition in 2 minutes essentially. There's some caveats in there, but
That's like a week or two's worth of Calc 2.
because they don't know what they're doing and they don't like my prickliness, so they've hired. He gave me the stink eye the other day, so it's come back to him that I've called him an inferior Math 115 instructor. Facts don't care about your feelings. I'm better than you. Okay, 81. I can't do it. 80. Half of 80 is 40. I could do that one in my head. 121. 120. Half of 120 is 60. Plus 1. 160. Half of 160 is 80. No. That was zip. It's what? Someone save me. And let me recalculate. 80, carry the 1, 84. Correct. Shut up. They can't hear you, Tim. I'm stealing your ideas. I'm bad with numbers, so you write it down. Now what is that going to say? So, step 1 in this algorithm. Take the odd number, square it. There's step 1. Step 2 is divide it by 2 to get the quotient, the unique quotient and the unique remainder. Now do you see we have 4, and you might think that there's a pattern in there at first too, because it's the only Pythagorean or the prime triple, but I get 4, 12, 24, but then it goes 40, 60, 84, it's all over the place. So what are we going to do? From that, we can take what? I need the Q is 4, do you see? That gave us the first Pythagorean triple, the 3, 4, 5 triangle. Step 3 is take Q and then add 1 to it. And then you have the Pythagorean triple 3, 4, 5. Oh, what's going to happen when we do the next one? Do you see what the next one's going to be? Lorenzo?
Yeah.
You already said, oh, he sees it.
12, and then 12 plus 1.
I put the quotient there because that means he's the hypotenuse.
Semicolon?
Then whatever, what did I say? I'm never wrong. Yeah, semicolon. A winky face. Winky,
There
winky.
you go.
Winky face. So now I don't even know what it is because I have never actually done this demographic for myself, or I did and I forgot. I found whole stacks of paper where that's my handwriting, but I don't remember doing that. So now what's it going to be? 7, 24, 25. See how easy?
Holy shit.
Yeah, 9, 40, 41. See how fast it's going to be? There's the algorithm. We just made it on the live stream in front of you. PowerPoint, PowerPoint, PowerPoint. Nay, kilowatt. 60, 61. I forgot my quotient.
Double check this, 'cause that's like.
Oh, it fucking works. I can prove it for you. There's one for even numbers too, but I'll see you next time and I'll show you how to do it with the even numbers.
Oh, so are we ending it on that? Because you listed like 20 things that you wanted.
Oh, what was I going to do next? What was? Oh, yeah, let's do that one. I erased it. You're like, are we ending on that? No. I've got a turtle on deck that could choke a donkey. Oh, you've seen that. Oh, have you seen So I Married an Axe Murderer? Hid. Pillow. Now. Oh, are you going to go cry on your gargantuan... He's got a fat head, so they bug him about it. Are you going to go cry on your gargantuan pillow? Tim likes what's happening.
Vacation movies where the chick's got to stick her ass out the window in the moving car because she's prairie dogging.
I'm kind of glad they can't hear him. Mine were at least a little bit PG. Everyone likes a poop joke.
Damn right they do.
Okay, I forgot what I was doing now again. Yeah.
Hey, Brian.
Theorem. Everybody thinks Euclid. Just a second. Let me go over here. Don't kick the camera.
We can still hear you, just so you know.
They can still. That crowd is a real piece of work over there today. Not even answering a bunch of crap. Oh, it might be in here. That's not what I came over here for. They might be in this one. And then this, it might be. These pages are all stuck together because I dropped water on it, Tim. I swear.
Oh, right.
That
Cool.
Your name might be in those. Martin Gardner.
Yep.
Martin Gardner was the genius. He's spread more mathematics to more people than anyone that I know of.
Rest beyond is what,
Yeah.
well, math groupies, they put out.
Yeah. I spilled water on that literally yesterday looking for it. I went to pull it out and then the water spilled all over it. I was like, damn it. How many years did it come down where it was in pristine condition and then I ruined it? The content is still there. I think Nim might be in there. So theorem, but everybody thinks of Euclid's Elements, but only the first few books are this. The rest of the books were number theory and a bunch of other stuff. So there are, and then this was Richard Guy. Hey Guy, I'm not your guy, buddy. I'm not your buddy, pal, friend, guy, pal. That's the funniest one. Pal is the only word where you use it. You never use it with an actual pal. It's like, yeah, pal. I'll get right to that. There are lazy 8 many primes. Did it freeze? Only you. My computer still says yes.
Yeah, yours is still good? Okay, let me
Yep.
keep going down. Sure, it's fine.
I'm going to keep going. Their computer froze. Can you hear me still?
Yeah, looks like it. OBS is still working. It's just.
Oh,
Yeah, OBS is still working. It's just.
yeah, he got an ad and then he got in. Oh, I know. We're trying to make money here, Noah. You're the only one showing up.
Noah's good.
Noah's good. He said he's got an ad. I'm also not reading them, but now I'm reading them. I'm gonna read them in succession. I got an ad. I know what that one is. Be right back. Don't use your shorthand, otherwise I'm not gonna know. You just did. I'm back. I can see stuff still. Stall. Use your. He can see stuff. Stall. Don't say sorry for it. Just correct it and keep going. So this one we're gonna use reductio ad absurdum. Which is, Mark calls it RAA. This is also proof by contradiction. Quite literally translated, it's reduced to an absurdity. I like what they called my honors degree in Latin. Cum laude. Okay, I will. Which is proof by contradiction. So it says it in the Latin. We're going to reduce it to absurdity. So, and I like the way that Mark does this, so I'll do it the way that Mark does it. Let's switch to, does brown show up? Oh, it does. Let's do assume for a contradiction. So what we're doing here is, this is debate or politics 101. You're never going to be convinced of my argument. So the strategy is by Zeno is to tear your argument apart. And so how do I do that? I take the premise of your assumption or your argument, and then I show that there's a logical absurdity in there, and therefore your assumption can't be true in the world. We're going to tone that back and just do it in mathematically. So assume, but Mark says for a contradiction because it reminds you what you're doing. Also, a contradiction has to have two statements to contradict them. That's also when you're proving these things, you're like, how do I do this? Well, you have to get, when we do this for at most two real roots, you say that by the Rolle's theorem, there has to be, the derivative is zero. And then you show using the actual function that the derivative is never zero, and those two statements contradict each other. That's how you do that with Calculus 114, that it comes up and you hate those problems. It's because it's reductio ad absurdum and nobody pointed it out. So assume for a contradiction, finitely many primes. Also, I'm going to do a couple of lemmas in here and wave the hands at them. You can prove them on your own, Noah, and then show either Lorenzo or me if you can find me at McEwen on Monday. That's tomorrow already? Shit. Why is there 7 days in the week?
It doesn't have to be.
And some lady at Concordia, I just about jumped down her throat, and then I was like, wait a second, remember where you are? And then her opinion of this is valid. She shouts out, because God said so. And I was like, wait a second, I want to tear that apart for a minute. Sorry, Noah. But also it's like, okay, but why did he pick 7? I said, oh, hi, kitty, squirrel, squirrel, come up here for a second. So, why are there 7, kitty? Because there were 7 wanderers in the night sky. The 5 planets they could see at the time, and the moon and the sun. And they weren't playing ball with the rest of them, going counterclockwise in the... Oh, I know. Look at your spiky spikes. I know, but you can't get me with them because I know how to hold a cat. You can't get me with any of them. Kitty.
There we go.
Are we frozen? No, I'm just frozen. I'm doing at the end of, what was that show?
That was also on an episode of South Park where, what was it, Officer Barb Brady learns how to read, and then he just holds a thumb up and he just...
Oh, here he Tim. Straight to Tim. So, assume for a contradiction that there's a finite list of primes. So what you could do is call P0 equal 2 and P1 equal 3, and then up to PK. I'm proving stuff, kitty. Shush up, back there. I like to also call it PK for the Hindi people in there, because PK in Hindi means little bit tipsy. So PK. Then, what do we know? How do you prove that there's no bound to the actual whole numbers? Think of the largest number Q that you would have, and then add 1 to that. It has to be larger. So what he does is he creates a Q, which is going to be the product of all of these guys, and then he adds 1 to it. I know. Come back. You wouldn't sit still though. Oh, you're dislocated. Oh, the woody, 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 woody. I know.
It's not a series, you know, Adrian teaches the cat math.
I know.
Yeah,
Okay.
we're doing a cat fever thing. Yeah.
We did it on the ukulele. Cat math fever. Dun, dun, dun. Then we're gonna have to pay Nugent. We're gonna have to pay the Nuge.
No, we're not.
Oh, because it's artistic license, right?
He has too many PDF files in his drawers.
Oh, does he?
Oh yeah, he got tangled up with some young jail date.
I don't like to look at the internet because it makes me depressed. I could do that on my own. No, the internet looks at me. That's fine. I don't want to look. If you stare too long into the abyss will stare onto you. This is Nietzsche. Let's not talk about Nietzsche too much either. Okay, so now what? Why is this? I have to throw a hand at this, but this is the least criminal. Do you know about the least criminal in mathematics? It's the first one that breaks it. We're going to do a least criminal in a second, Lorenzo. So, least criminal. Write that down. Yeah, write that down. No, you're being ignorant. That's ignorant. Chishamone. That's ignorant.
Half of this has just been quoting South Park.
Blanket, you're ignorant. That's ignorant.
Yeah, no, that's a good thing.
So
South Park.
we have a lemma that says that every number, and you use the least criminal in the proof of this. Every number meaning positive integer, larger than 1, p larger than 1, so the assumptions in there, 1 is not prime, he's the magic guy, is either prime or a product of primes. There. So I need this lemma. What's the lemma? I need it for my theorem, but it's not as interesting to me. The infinitely many primes is interesting, so they call this lemma. Something I need. You can prove this. It's in a number theory book. I have a good number theory book. I'm not going to look for it right now. So why does that break it? This is the one statement, and then I'm going to deduce from this guy right here that it contradicts this. Do you see why? It's either composite or prime. Product of primes means composite, is what I want to say. Do you see why?
Assume the largest.
Well, is Q a prime? No, because it's not in my list. So Q is not prime, as I had a finite list. And he's larger than every one of these guys because I've added 1. I've multiplied them together and added 1. So Q is larger than each one of these, and I said I had a finite list of prime numbers. So he can't be a prime number. So this one's out. And then why isn't it composite? Can you see? Any one of these primes, if I divide it, will leave a remainder of 1. So Q divided by any one of these pi leaves a remainder of 1. That says remainder. And then hence, therefore, Q is not composite, which is the contradiction. Therefore, there has to be infinitely many primes. That's genius. But now, can you find the least criminal? Which I had never thought about also, because you would assume, if you look at this, let's assume that our complete list of prime numbers, so in there, let's look at the Q's. Let's look at, let's assume our complete list of primes is just 2. There's only 2 is the only prime number. So then 2, you multiply them all together and add 1, you get 3. That's also a prime number. Actually not in the list, right? Now let's assume it's 2 and 3 is your finite list of numbers. Then what do I get? 2 times 3 plus 1 is 7, which gives you a new prime. Not the next prime, though, because it's 5 is the next prime. So it seems like Q is producing a prime every time. Is this a true statement? Can you prove it by mathematical induction? No, because there's a least criminal. There's a least statement where one of these is going to fail, which is like he wouldn't assume it would. But what was wrong with it? I only used this in an argument which was reductio ad Morty. Hey Morty, which was
Oh, geez, oh man.
oh geez oh man, it was reductio ad absurdum. So let's pick the next one. Does it work? Yes. 2 times 3 times 5 is 30 plus 1 is 31 prime. Check. So let's assume the 7's in there. Uh-oh. Calculators, guys. 2 times 3 times 5, I already said was 30 times 7.
That's 217.
No, 210 plus 1.
No, 31 times 31.
No, 30. It has to be just the primes multiplied together. So 30 times 7 is 210, plus 1 is 211, which is a prime number. Now if I pick the next one, which will be 11, now you have to take 2 times 3 times 5 times 7 times 11. So that would be 210 times 11 if I'm not going to use a calculator, which is going to be what? 210, no, that was my dyslexia, sorry about that. 0, 210, which should be 0, 1, 3, 2 plus 1. Is that a prime number? This is where we're going to end. You find the least criminal. And then next time, that'll segue into it. We'll give the even case of this Pythagorean triple. And here's a magic thing that I want to point out. As we leave, I'm going to say it out loud so I don't forget. I hear you, but just a second. I need kitty snuggles, apparently. I used an odd number, and I can create a Pythagorean triple. You can use any even number, and you can get a Pythagorean triple. And that doesn't produce all Pythagorean triples. So can you find the fundamental set which will find these? I need complex variables a little bit, and then we're going to use primitive nth roots, and then we can find the complete list of Pythagorean triples. Having said that, the other thing I want to do is, can you tell me with this is the strong law of small numbers by Richard Guy. And he says the proof is by intimidation. You can't tell when you have a pattern. This is why we want induction. It would seem like using induction, all of these are primes, Fermat primes and Fermat numbers. But the next one that he couldn't compute because it was in the billions turns out to be, Euler shows that it is composite. It has 631 in it. Fermat numbers are Fn equals 2 to the 2 to the n plus 1, I believe, or minus 1. Plus 1, because Mersenne numbers is 2 to the n minus 1, which is the number of moves in the Tower of Hanoi. And Recursion relation. If you had Tn equals 2 times Tn minus 1 plus 1, the solution to that is a Mersenne number. Every Mersenne number creates, if you calculate this and the prime, if n is prime and this thing is also prime, it creates a perfect number. Do you want to see how that works? Okay, well, you said we were going to end, but then that's how my brain works. This chalk is awfully, I'm going to sneeze. So if I take n equals 3, then what do I want to do? I want to do 2 to the 3 minus 1. Let's use 2. 2 is the first one. That'll give me 28. 2 is prime. The Beatles had it wrong. 1 is the loneliest number. Unless you're 2, 2 is the loneliest number in the set of primes because he's the only even one. So he's the only woman in that set of primes. Oh, there's a joke in there I'm going to not talk about. So 2 to the 2 minus 1 gives me what? 3. So this is also Euclid. Euclid says if those guys are both primes, then you can take those numbers and you can take this number and you get a perfect number. What was the next one? N equals 3 would give me 2 to the 3 minus 1 gives me 7. And so what you have to do is it's actually 2 to the 3 minus 1 times 7 equals 2 to the 2 times 7, which is 28. The next perfect number. Oh,
We're ending on that one now.
yeah. See you next time. Find the first one where this fails. You need induction because infinity is an extremely long time, especially towards the end. Another pederast, Woody Allen.